Let's talk through a few more additional considerations as we design for PaaS and things to consider here. So first of all, relying on async messaging, using queuing, thinking in queues and handoffs, not tightly coupling services or something you're really going to look closely for. So again, you can easily scale out individual tiers versus necessarily having to scale groups of applications components because they're all tightly coupled, and if workload increases here, that means it has to increase here. You want to make sure you can have some independent scale vectors. And that comes from composing applications out of services, thinking in microservices, to use a hot term, but the idea of continuing to take individual bits of work, not build monolithic apps, and instead compose applications out of these services, especially a PaaS environment's great for that, where I can scale them as needed, they can have their own application lifecycle, and so forth. I'm composing applications from those. Think about portability. Portability, on one hand, can be overrated because how often are apps moving between entirely different environments? But at the same time, it can also be underrated because the ability to easily move from local dev to production or move from one PaaS to another, there are legitimate use cases for wanting to do that. So think about, what are the provider-specific hooks that are part of the app? Did I build something in this app that only works in this runtime or in this hosting provider? Or did I build something where I could run this locally, I could run it publicly, I could switch PaaS providers, I could do whatever I want? Does that matter to you? And if so, you're going to design a little differently. It's important to embrace the abstraction. At the end of the day, PaaS is a relatively opinionated system. It tells you what it thinks the state of the world should look like, it gives some constraints, and those constraints are either going to annoy you or free you. Hopefully they free you, because now you have to be a little creative in different ways, because you just can't do certain things in a PaaS because it's a multi-tenant, shared, secure environment that has certain constraints put in there on purpose. So if I can embrace those constraints, embrace the abstraction, I'm creative on top of it. Now there's not 9 ways to solve the same problem, there's 1 or 2. And now I use that to actually solve the problem versus debating endlessly my 50 choices. I'll briefly talk about anti-patterns. Some of these should now be pretty obvious as we talk through the 12-factor app, but relying on the local file system, big no-no. Right? This is something where a file system is short-lived, it's not shared among any other instances, it's meant to be at the most a cache. It's something to worry about, but if you're used to writing log files or having local configuration files or things like that, that's not going to be a good application for PaaS. An anti-pattern is building services that are really meant to scale up. Hey, this instance simply needs more horsepower. I need to give it more CPU, more memory, more storage. That's how I scale. It's not typically how PaaS is meant to work. PaaS is meant to work by scaling out to more and more instances. And while you may scale up also, because sometimes you may start slow and not want to over-provision, you want to scale up before you have to scale out, fantastic. But you should be thinking about a multi-instance world where I can tear down and turn on things that run. Otherwise, it's not going to be a great PaaS fit. We talked about with the 12-factor apps that you really don't want to ever be changing things at runtime. So if you're used to being able to log into production and changing code and manipulating things, that's not going to work in a PaaS environment. It really follows a pipeline of deploying code, having it immutable until the next release. You don't really want to be manually coordinating builds either, where you're adding libraries to projects and you're hand building things and then you're deploying it. And it's not going to work great in cloud. I want my application build and deployment to be automated, repeatable, something I can do consistently. I don't want to have this be a science project every time I push my app. Clearly, as we've also talked about, you don't want hard-coded configs. You're going to want to avoid that wherever possible. I'm sure I did it a couple times in demo code to make it simpler on myself, but as you're doing this in production, you really want to look at any sort of place where a setting is going to be different between environments and extract that, pull that out of the environment. And then finally, monolithic apps. Monolithic apps don't work in a PaaS. I don't want to take my big giant app that has everything embedded in the same web app and push that to a PaaS. Will it run? Yes, probably. Is that how it's supposed to work? Absolutely not. I want to make sure that my app is made up of decomposed services that I can assemble at runtime, scale independently, and give independent life cycles so that I can update things strategically without having to coordinate a massive deployment of an entire monolithic app. So let's talk a little bit about Cloud Foundry now. It's an open source platform as a service for running orchestrated polyglot applications in a public or private environment. I can run Cloud Foundry public or private. Polyglot meaning it supports a number of languages, so I can deploy them all to the same place. It's orchestrated, so it's coordinated work, it's health monitored, it's all those sort of things, and it's open source. You can download it today for free, you can contribute to it, you can see very publicly what they're working on, a number of things that really make this an attractive environment. Let's talk a little bit about the architecture now. How is Cloud Foundry put together? Just briefly, so you understand this. You'll never have to interface technically with a lot of this, but it is good to understand how is it put under the covers so you know and you can understand when it writes certain log messages or when it's doing certain things, how it's working. The bottom tier, this metrics and logging, really this metrics collector underneath the covers is collecting metrics from all the different components. An operator, someone actually running a Cloud Foundry environment, can use this to monitor an instance of it. The log aggregator streams all these application logs to developers. So that's actually a good part where we will interface with some of that. The messaging layer is, again, something you're not going to interface with. It uses a technology called NATS. I think it stands for Not Another TIBCO Server from the original Cloud Foundry. And this is something that it's a lightweight pub sub engine. This is what the internal communications between components uses. So it's great for the sort of system communication. You're not really using it for app-level messaging. That's when you would use RabbitMQ. That's when you would use something else for queuing. But this is what's underlying the system when it sends messages between different things and communicates. At the services layer, this is the service brokers, and we'll talk about this a lot more in the next module, but services are integrated into Cloud Foundry by implementing a specific API they've given to the service providers, and then the controller is the client. We'll talk about the cloud controller in a minute, but it calls that broker API. So if I'm a broker, I'm a third party who wants to provide a MySQL database, a cache, a queue, a whatever, a log service, I implement that API, and then the broker is able to communicate with that when it comes to provisioning things or deleting things or starting things up or binding them to apps. Then Cloud Foundry can call that API and work with that endpoint broker. The app storage and execution is made up of a few things. It's made up of blob storage. Blob storage holds the actual application code. The build packs, which we'll talk about in a little bit, but each language has a build pack. .NET or Java or Ruby or Go or PHP, all are represented by a build pack that knows how to deal with each application framework. Droplets are pieces that get actually composed into the app, and we'll talk about this later, but that also gets stored there. What that means is that because it's being stored, I can immediately take that code and put that on new instances when other ones fail. So I'm ready to go. I've already got a cache of the application instance that I can deploy quickly. The DEA, or the Droplet Execution Agent, this is really what manages the containers that run the applications. It stages applications to generate those droplets that I can then use as a cache. It monitors the state of a started application and broadcasts that state messages over NATS for consumption by the health tool. Warden is the container technology in Cloud Foundry. It manages the isolated, ephemeral, meaning they can go away, resource-controlled environments. Resource-controlled, a container has so much amount of CPU or memory or disk usage it's allowed. The goal of Warden, why it was created, is to provide really simple API and process for managing isolated environments. It only supported on Linux today, but really they purposely built it not to be dependent on things like LXC or Linux containers so that it could run on other environments as well. So it only works today provided on Linux, but there's a lot of work underway, and others have made this work on Windows as well by extending Cloud Foundry. If we move up to the application lifecycle, the cloud controller is something you interface with a lot. This is responsible for managing the lifecycle of apps. When you push an app, you're really pushing it through the cloud controller that then stores the application bits in the blob storage. It creates a record and tracks some information about each application, chooses a DEA node to stage and run the application. It also maintains a record of all the spaces and organization we'll talk about in a few moments, service instances and things like that. The health manager is responsible for monitoring an application state, instance counts, and reconciling mismatches. So it's really making sure that an app running on Cloud Foundry is available. It'll restart an app if it notices an app got shut down for a negative reason, and if an app is actually killed, if Warden container goes away because it wasn't supposed to, something bad happened, it can actually start one back up again. This is actually written in Go, and it's more modular than the original Ruby implementation that they created. And you're seeing more and more of Cloud Foundry being written in Go versus the original Ruby, and this is one of those components. The authentication layer, you'll see, obviously, as you log in, the OAuth 2 server that's out there using the UAA, the User Access and Identity sort of service. They work together to give identity management. It's really for logging in and managing users within the Cloud Foundry environment. You're not necessarily using this within your app itself, but you're using it to interface with the Cloud Foundry environment as you push and manage apps. And then finally, the routing tier. This is really where traffic comes in from the public internet and routes it to the individual component. Usually the cloud controller or the running app that's sitting on the DEA node are really your two typical destinations, because you're either pushing an app or you actually have your application traffic. Here's when we did our hello world and we hit it in the browser, that goes through the router into the Warden container that was running our application droplet. The router is also written in Go, as again you've seen more and more components written, switched from Ruby to Go. And this again is a big component of what you interface with as an end user. If we briefly talk about security, really as we think about the security in Cloud Foundry comes from a few dimensions. There's system boundaries, right? There's the Cloud Foundry itself, underneath the covers, has a limited number of contact points with the public internet. They reduce the attack surface and surface area so that only traffic goes under a certain level as it hits within the VMs within themselves. It's purposely meant to isolate itself so that it has a very small attack surface. The routing is done through SSL. You're making sure that the traffic flows securely between various components, encryption where needed. There's a number of firewall rules in place to make sure that applications don't jump between their containers. You're making sure that something can't communicate outside of its container. It's also set up to make sure customer applications can't try to do loopbacks and other things to look outside of their container. So it's done as a proactive way and also made sure that things that are supposed to be isolated stay isolated. We talked a little bit about authentication and authorization, but all of the access to Cloud Foundry, the command line interface, the API, the web-based console, all of that goes through the user account and authentication server, the UAA components. Sensitive credentials get encrypted, and authorization happens through that cloud controller. So there's a very smart authorization policy and authentication policy. And there's a lot of role-based access, which we'll play with just a little bit, but each role has different permissions within an organization and space within the environment so that you don't have to give Uber access to everyone in the application. And then finally, you have this idea of application isolation. Because you have self-contained environments, these Warden containers, you're blocked from interacting with other applications, other Cloud Foundry system components. And so even as applications invoke other Cloud Foundry applications, so I've got a system made up of multiple applications and services, those still typically leave the system and come back through the load balancer in front of the router. So that's important, so that you still don't have kind of a way to tunnel between the two. Everything still securely should happen between the infrastructure provided. You're not short-circuiting any of that. Let's briefly talk about Cloud Foundry and containers. I've already talked about Warden just a little bit, but let's answer some top-level questions. Specifically, as we think about Cloud Foundry and we think about Docker and technologies that, if you haven't heard of Docker, you might not be paying attention, frankly, but does Cloud Foundry use containers? Yes. So Warden is for isolated, resource-constrained containers. It originally used LXC, the Linux container technology that's the basis of Docker and others. Right now it uses control groups or C groups, where each container is placed in its own control group and it's configured to use a particular slice of CPU and memory and things like that. The reason they moved away from using LXC was that was tied to Linux. And while you could implement a Warden backend in any operating system, that was the key, is they didn't want to necessarily tie Warden just to a Linux container technology. They wanted to make sure that they provided a way that this could run in multiple places. So definitely uses a container-based model of isolation and resource slicing within a particular physical or virtual machine, but it's not using LXC or it's not using Docker directly. So what about Docker? So clearly Docker is amazingly a hot technology. They're doing fantastic stuff, and some of the work upcoming with Cloud Foundry with the Diego project, which is DEA and Go, as they're writing more Go with the underlying platform, but it has a different and elastic runtime. It's using a new orchestration manager that will support different backends. So I could plug in a Docker container, I can continue to use Warden, I can do all of that sort of stuff. So what you're going to see moving forward, which is exciting, is that Cloud Foundry's been using containers for years. It's clearly a successful model. And now as Docker has become really mainstream and more adopted, and the new version of Cloud Foundry will let you drop in just another Docker container. So all the things we're learning here in this course are still as relevant in the new model as they are in the old model. The command line interface, the way we work with Cloud Foundry will be the same. It's just going to keep getting better with letting you drop in more types of components into the environment. briefly talk a little bit about the community. So where can you find stuff? Well, the Cloud Foundry itself is a foundation. If you go to cloudfoundry.org, you can read about the different foundation partners. A number of major providers and industry leaders have jumped on board to make sure they're contributing to the project, providing guidance to it. So really exciting to see such a vibrant, healthy ecosystem. You can see the open source repo at github.com/cloudfoundry. This is where you can see some tools. You can see the actual source code. You can deliver pull requests. You can do a number of things and help contribute to making this better and better. You can even look at their public roadmap. I did a quick bit.ly link to make it a little shorter, but you can view their public roadmap. They keep things out in the open. Again, they're trying to run this as a true open source project. And there's a good ecosystem. There's service providers out there like Pivotal, who we just signed up for. Active State does a great job. CenturyLink, my employer who I work for, has a Cloud Foundry environment. IBM is in the mix. HP is in the mix. Really good, high-quality service providers in the place. Marketplace offerings, you'll see as we play with some of them, but around data storage, SendGrid, New Relic, Load Impact, a number of who have jumped in and made sure their tools work in the Cloud Foundry environment. And you'll even see consultancies, Altero, Stark & Wayne, Open Credo, a number who have jumped into the ecosystem and even help others get going with it. So let's talk a little bit about the plan for the course. What's the course objective? Understand PaaS apps. We've already started that in this module, but as we think about platform as a service, what makes good sense? What are the right types of PaaS apps? We're going to learn the Cloud Foundry command line interface. You're going to be really comfortable with this by the end of the course. You're going to feel great about pushing apps, scaling apps, recovering apps, looking at logs, troubleshooting. All of that's really part of the course is make you really comfortable using and working in a Cloud Foundry environment. And finally, that build, deploy, manage apps. You're not just learning commands on a command line because you can look those up, but you want to understand what's behind it. What does it mean to build and manage applications? How do I scale things? So it's more than tools. It's understanding what's behind it. So that's going to be hopefully an exciting part of what we're doing here. The reference architecture for the first part of the course, the next module, really looks at a donation sort of website. Let's assume we're taking donations for candidates for office or for a charity. And so it's going to have a few different services. You'll have a web application tier written in Ruby. We'll have a JavaScript Node.js backend for a RESTful API. And we'll actually be doing our persistent storage in MongoDB. Now we're going to extend this in Module 3 to even have some more components. But this is what gets us started. And we're going to see how we deploy these different types of components and scale them. The key is you don't have to know Ruby, you don't have to know Node.js, and you don't have to know MongoDB. You just have to know how to push them, because I've already built the apps for us and we're going to work with them. So don't worry about it if you don't know these technologies intensely. We'll look at some source code occasionally, but no expectation that you're coming in here with expertise. We're just simply going to take some canned applications I built and push those out. So a quick review. We talked about cloud application delivery models, where PaaS fits in that spectrum with software as a service, infrastructure as a service, how it adds unique value. We actually pushed an application. You did your first Hello World and got that out there. Hopefully it gave you a good sense of what does it mean to push and deploy a Cloud Foundry app. We went through the 12-factor app considerations because those are really important. That is what next generation of apps are really going to be like, which is very stateless, very scalable, configuration-driven, very synchronized between environments, very repeatable. These are the things that are going to make application deployment really something that accelerates here in this current generation of new tools and new technologies. By making things standardized, repeatable, scalable, we're opening up the opportunity to do some pretty great things. We talked a little bit about Cloud Foundry and the architecture, the security model, the foundation, the community, about how it all works. We discussed a little bit about containers, just understanding the great role that containers play already in Cloud Foundry and what they'll play in the future. And we talked about the course plan and reference architecture. I hope you're excited about this. I've had a lot of fun putting this together, and through these next few modules, we'll talk next about deploying applications, we'll talk about scaling them, we'll have some fun building all of this out. In the third one, we'll do some advanced things. We'll look at doing worker roles. We'll look at how we handle automated crash recovery. We'll be doing a number of exciting things as we continue to grow our knowledge together of what Cloud Foundry is.